Now let us see the types of sets. First we have null set, or what we call the void set. So what is a null set? It is simply a set with no elements at all. It is denoted by the symbol phi, or we denoted by the curly braces with no element in it. Okay, so let us give an example. So if I say we have A is a set, okay, which contains all x's such that x is an even prime number greater than 2. So what will be the elements in set A? So we know the even numbers start from 2. So first even number is 2, then we have 3, then 5, then 7, then we have 11, then 13, and so on. These are all what we call prime numbers. Since we have to find out the elements in the set where we have even prime numbers greater than 2. So the prime numbers greater than 2 all odd. They are all odd. Okay, so in this set we will have no element at all. Okay, because there is no prime number greater than 2 which is even. So A will be a null set here. Okay, this is an example of null set. Then let us take another type of set, what we call the singleton set. So a set containing only one element is called a singleton set. Containing only one element. Let us suppose we have a set A and we have only one element here. Let us suppose this as, let us take L. So we say this is a singleton set because it contains only one element. Okay, then we have another type of set, what we call the finite set. Okay, so a set with limited or countable number of elements is called finite set. So we can write a set with limited number of elements or countable number of elements is called a finite set. So if I take an example, A is a set. Let us suppose such that A contains all x's such that x is prime number less than 10. Okay, so let us see what will be the elements in it. So first prime number is 2, then we have 3, then we have 5, okay, then we have 7. Okay, so this we can say, since we can count the number of elements here, this is a finite set. Okay, then let us take other sets also. Then we have infinite set. So it is very simple. A set that contains unlimited number of or uncountable number of elements. A set containing unlimited or uncountable number of elements. For example, we have a set which contains the natural numbers. So we have 1, 2, 3, the set of all natural numbers, then we have and so on up to infinity. So we cannot count all natural numbers, so this set will be called an infinite set. So we can also write it like this: A is a set A contains all x such that x is or x belongs to natural numbers. Okay, if we have this condition, so we have the natural numbers and there is no restriction on the number of elements in it, so this is an infinite set. Simple. Then another type of set is what we call let us take, or let me rub this out first. So then we have equal sets. Okay, so two sets are said to be equal. Let me write it here. Two sets are said to be equal, okay, if they contain exactly same number of elements. Okay, so exactly same number of elements. By this what we mean, if we have a set A which contains numbers 1, 2 and 3, then we have another set B which also contains let us suppose 2, 3, 1. Here order does not change. Since the number of elements in both the sets are equal and we have same elements in both the sets, we say set A and set B, these are equal sets. Okay, so here we have 1, 2, 3, here we have 2, 3, 1. So order does not matter, we say these are equal sets. Okay, two sets are said to be equal if they contain exactly same number of elements. Why I am stressing on this exactly same? Let's compare it with the equivalent sets. Sorry for the spelling mistake if I have here. Equivalent sets. Okay, now what are equivalent sets? We say two sets are equivalent, and let me write it here. Two sets are equivalent sets if they have same number of elements. Number of elements, regardless of what the elements are or what those elements are. Okay, if two sets have same number of elements or equal number of, or let me put it like this, same number of elements regardless of what those elements are. If I take a set, let us suppose A is a set which contains number 1, 2 and 3, then I have another set B which contains let us suppose 5, 6, 7. We say these two sets are equivalent sets. Okay, if we, or regardless what the elements are, if the number of elements are same, they are equivalent. Okay, it does not matter what elements are those, the only condition is that number of elements should be equal. Or if I take here to make it more understandable, so let's take A, B and C. I am saying that A and B are equivalent sets because they have same number of elements here, and we do not care about what those elements are. Okay, unlike in case of equal sets where the number of elements should be equal and the elements should be same. Okay, so let me write this out. Then we have overlapping sets. Overlapping set. So we say two sets or set containing, let me write it here, sets containing at least one common element. So if I have set A, let us say 1, 2, 3, I have set B where I have 1, 2, 3, 4. If two sets have at least one common element, here we have two common elements. Okay, it doesn't matter, at least one common element should be there, then we say the sets are overlapping sets. Here I can say A and B are overlapping sets. Okay, now then we have disjoint sets. So it's opposite, that is sets, let me write it here, sets which have no common elements. Let us suppose we have a set 1, 2, 3, another set is B which contains 5, 6, 8. Okay, these two are disjoint sets because they have no common element. Okay, so let me wrap this also. Then we have proper subset. Okay, and improper subset. So let us first define proper subset. We say, let us take two sets. I am saying set A is a proper subset of set B. Okay, if all elements of set A are also in set B and there is at least one element in set B which is not in set A. Okay, so by this what we mean, so let me take an example to explain it. Let us suppose we have a set A where we have elements 1 and 2, and I have another set B where we have 1, 2, 3 and 4. Okay, and in this case I say that set A is a proper set of B. Okay, if set B contains all elements of A and set B has at least one element that is not in set A. Here you can see set A has elements 1, 2, B has also elements 1, 2, so all elements of A are in this set B, but there are some elements in B which are not in set A, so we denote it by A, then we use this symbol B. We say A is a proper subset of B. Now what about improper subset? So let us explain it here. Improper subset. Now we need to define the improper subset, and let me write the definition. We say set A is improper subset of set B if all elements of set A are also in B, and A is equal to B. So by this what we mean? So if I take a set, we have 1, 2 and 3, and I take another set where I have the same number of elements and same elements, obviously. In this case, I say A is a proper subset of B because B contains all elements of A, and also A contains all elements of B. So in this case, we say A is a proper subset of B. So it is denoted by A by this symbol. Okay, so here we can say that A is, because here we have set B contains all number of elements which are in set A, or we can also say here, and here we have also B is a subset of A. Okay, so we say set A is improper subset of B if all elements, here you can see, of A are also in the set B, and A is equal to B. That means number of elements in A are equal to number of elements in B. Okay, so now this symbol is exclusively, if we write this symbol is exclusively used for showing proper subsets. Okay, proper subset, while as this symbol represents any subset, okay, including the improper set. Okay, so this is the difference between this symbol and this. So this is exclusively used for showing the proper subset, and this symbol is represents any subset, okay, including the improper subset. So if I say, so A contains elements 1, 2, and B contains elements, let us say 1, 2. I don't have the space here, so I hope you got the idea what I meant by this.